Hello and welcome to my channel. I'm starting a new project today. I'm very excited to share it with you. So let's get right into the project itself. Okay, the project I'm talking about is Loan Shark. It's a very simple interactive browser game that I'm planning to build. And in this game, the player will take role of a loan lender. For them, I'm calling Loan Shark. And the game concept is very simple. First, we will show some details of the applicant who are presenting a loan application. We'll show features like income, credit score, and age. And then, based on this data, the player will decide whether to approve or reject the loan. And if they decide to approve, they will also provide additional data like interest rate and loan tenure. Now, combined with the applicant details, the data provided by player will form what is called an input feature vector for a machine learning model. Yes, we will have machine learning model in this project, which will train ourselves, and the machine learning model will then predict whether this loan will default or not. Based on the prediction made by the model, the player will be either rewarded or penalized. If the loan defaults, meaning the borrower was unable to repay the loan, the lender will lose the loan amount, but they will receive the property value. And if the loan does not default, then the player will earn their repayment as well as the total interest. The objective of this game for the player acting as the lender will be to maximize this profit in form of the interest while minimizing the loss due to the loan being defaulted. The concept is very simple, and I think this will be a very fun project to do. But unfortunately, I don't think I will be able to complete the whole project in a single video. But I will train a binary classifier model today for this project. And if you are following along, then you will also have one binary classifier model at the end of this video. The requirements are not that fancy. I am going to build the whole project in .NET 10. So make sure to have .NET 10 SDK installed on your machine if you are planning to follow along. And the IDE that I'm going to use is Visual Studio Code. And I'm also going to recommend having C# DevKit and .NET Extension Pack extensions installed in this IDE. Okay, so this is all for us to get started. The first step of setting up the project to train the binary classifier model is just creating a new file. I will name the file train model.cs. Okay, so this is just going to be a plain C# file. Now, if you are familiar with .NET, then you may have seen a .NET project being created instead of a single file. But today I'm going to use what is called a file-based app in .NET 10. .NET 10. So in .NET 10, we can just write the C# code in a single file instead of creating a whole project. Let me just write a quick hello world. Okay, and then I can just go ahead in my terminal and I can just do .NET train model.cs because I'm in the same directory and this is the name of the file, and the code will just run on its own. Yeah, we can do write everything that the framework provides by default. For example, the system namespace from where this console is coming from. But to do things like training a machine learning model, we will need to depend on some NuGet packages as well. So the packages that we are going to need, uh, the packages we are going to need are Microsoft Data Analysis and Microsoft.ml. Let me just increase the zoom level here. So let me go to the NuGet website. Okay, so the first NuGet package that we are going to use is Microsoft.data.analysis. This is the one. And now there are a couple of there are a bunch of options to use this package, but we are going to use file-based app. So I'm just going to copy the syntax here, go to my code, and then I'm going to paste it right here. The other NuGet package that we are going to use is Microsoft.ml. This is the one. So similar to the other one, I'm going to copy the syntax for file-based apps. I'll just copy this, go to my code, and paste it here. Now, after I do this, I can use everything provided by these packages in this file. And when I do .NET, the name of the file, then everything should work as expected. We have the dependencies referenced. Now the next thing to do is actually get the data on which we can train our model on. I'm going to use the lone default data set from Kaggle. Of course, I'm going to post the link to this dataset in the description of this video. If you want, you can explore the data on your own from this website. You can go through the data card. You can go to the code section to see what other people have built with this dataset and all. But we are not going to discuss a lot about the data in this video. I'm just going to go ahead and download the data. I'm just going to download a zip file. Okay, so my download is done. I have downloaded the zip file and now I'm going to extract it. So I'm going to just extract it to the location of my project, which is just the desktop folder, the lone sharp folder, and then I'm going to extract it right here. Okay, that is done. That is done. So I have the data right here. I'm going to rename it to something simple like data.csv. So we have everything ready to start training the model now. We have the data, we have the packages referenced in our file. Okay, so let's get started by loading the data in our file first. Going to remove this code. Now I'm going to load the data in what is called a data frame provided by the Microsoft Data Analysis package. I'll just name it data frame, and we load it using the static method in the data frame class. Load CSV. The name of the CSV file is data.csv in our case. Okay, so what is a data frame? If you are already familiar with tools like pandas in Python or our programming language, then you probably already know what a data frame is. It's just a tabular data represented in programs. Okay, so by tabular data, we mean it will have columns and rows. Okay. So for example, a CSV file is a tabular data. In our case, we have columns like ID, year, loan limit, gender, and all. And we also have all this data represented as rows. Okay, so horizontal structure are rows, vertical structures are columns. Now, while navigating through the data frame, let's say I want the loan limit for the third row. Okay, so this is the third row. I want to loan limit for the third row. What I can do is I can just do console dot write line. I can navigate through the data frame in this way. First, I can provide the column name. So I want the loan limit. Make sure the column name matches exactly with the CSV file here. It's loan limit, all lowercase. Copy this, paste it here. And then for the third row, I just want to give the index of 2. Okay, so loan limit for third row. So if you see the CSV file, so first, second, third, this is the third row, and the value of loan limit, which I think is better clear in this view. So the loan limit for the third row is CF. So we should expect the output of this to be CF. Let's see. Let's see the data. And just as expected, the value is here. This is how we can navigate through the data frame. But what if we want to see all the values for the third row? Let's see, not only loan limit, we want to see values for all the columns. In that case, we can actually loop through the columns in a data frame. I just use a for each loop here for column in data frame dot columns. Okay, so this will contain all the columns of the data frame, and I can do something like this: console dot write line. I can say column dot name to get the name of the column, and for the data, I'm just interested in the third row, so I'll just say data frame column dot name, and then for the third row, I'll give the index of 2. So if I run this, I should see all the values for the third row. So I should see this data in my console. Okay, so let's just verify one data very quickly. For example, the loan amount should be 406500, and the loan amount is indeed 406500. So this is how I can navigate through the data frame and see all the data and do whatever I want with it. Now, one thing immediately box me is the names of the columns here. So ID is in all caps, and we have year in all lowercase. In gender, the only the Z is capitalized. So I want to make this uniform. Let me just do that real quick. Instead of uh, writing this in the console, I'm just going to do something else. I'm just going to rename the column. So whatever name the column currently has, I want to change that to lowercase. Okay, now if we see all the columns name real quickly, let's just see the column name, and we should see all of the names in lowercase. Okay, and now we have all the column names in lowercase. This is much better. So we don't actually need to see it. That was just for verification. Now we have renamed the column. The next thing that I notice are there are a lot of columns in the data, but we also need to show all these features in the UI. If you remember, the idea of the project is to build a game, and I don't think we will be required to show all these features in the UI, especially because not all of these columns are very straightforward for a layman like me to understand. For example, I don't know what this means, and I don't expect a normal user to be familiar with all these technical concepts. The other reason is I don't think all of these are very important for the machine learning model to make accurate predictions. So I already have a curated list of columns that I'm going to use. I'm just going to paste the code here so that you can see what are the columns that I have chosen for this project. Now, if you see, I have just a handful of columns here. I'm going to remove everything else, every other columns from the data frame. So how do I do that? I will again look to the columns, and whatever column, so I just need to first find the column's name, which is just column.name. And for all the columns that are not in the relevant columns array that I have built here, not, so exclamation sign for not. So this will check if the name of this column is not in this array. In this case, I'm going to just remove the column, and this is how I can do it. Okay, I think this is pretty straightforward. I'm just deleting the columns from the data frame if they are not in my relevant columns array here. Let me just run this real quick. And I got an error. Okay, so the error says collection was modified, enumeration operation may not execute. Now the reason for this error is because I am iterating through a collection data frame dot columns, and I am making changes in that collection itself. Now this cannot be done because the loop expects this enumerable to remain same throughout all the iterations. What I can do instead is iterate in some other array and then do my operations here. For example, what I can do is I can create the column names is a separate array, okay, which is just data frame dot columns dot, I'm going to use the link query column. I'm just going to select the names here, and notice I have used spread syntax to create an array. So this will give me all the column names. I can do something like this, and I'll change this to column name now. make some correction here and here. Now it should work just fine. Okay, so the code executes without any error. I'm actually going to make some additional changes here. So instead of just selecting the column name, I'm going to move this filter. Yeah, I'm just going to move this filter here, and I'm going to add a where query. I'll just say column name, and I'll just paste it here. So now in the column names, I already applied the filter. So I have all the names of the columns which are not in this array. I'll instead of column names, I'll just call it irrelevant columns, because they are the names of the columns which are not relevant, so irrelevant columns. And I'm going to loop through the irrelevant columns. I don't need to check anything here because the filter is already applied. Okay, so these are the columns that I'm going to be using. Let's just see what are the columns that we have real quick. I'll just see the columns name, run this real quick. And here we have just a handful of columns. So if you want to verify, then these are exactly the columns that I have in the relevant columns name here. If you want to verify, you can go ahead and do it. But for now, I think we are good. The other important thing that you should notice is we are training a binary classifier model. And in binary classifier model, we have two different types of columns. So the first one is features, which will have all data used is input for the model. And we have something called label, which is the uh, output of the model. Okay, and by output we mean the prediction. Okay, so it's customary to represent features by X and label by Y. So I just leave that notation here. In our case, okay, so in our case, we are trying to predict whether this loan will default or not. That is our primary objective. And the data in the CSV file, the column that represents that information is the status column. Okay, so if you see, the status values are either 1 or 0. And in our case, this is the label, because we are trying to predict whether the status will be 0 or 1. And except for the status, everything else will be features for us. Okay. Now, since we are training a binary classifier model, okay, the label can have two possible values. Sorry, two possible values. Okay. In our case, the status can be 0 or 1. 0 or 1. Okay. Now, having said this, let's actually see what else we need to do. Let's see. So in the data, okay, so one thing that I noticed is that we have a bunch of null values here. So missing in the CSV file will translate to null values in the data frame. So before actually moving to training the model, I will first handle that. So now we will be handling the null values. Okay, I'll just say missing values. Okay, but before we do that, I want you to take a note of one other thing. Okay, let's just see the data here. So if you see, not all columns have data of the same type. For example, the loan limit is a string, gender is a string, but loan amount is a number. So there are two types of column that we have to deal with. Two types of columns. Okay, they are numeric, which will have float data, and string, sorry, I'll just say categorical features which will have string data in them. Now we need to handle this separately. So I'll obviously look through the columns first, and then I will need a flag that will check if the column is numeric or not. Now, fortunately, in the data frame column, I already have that method is numeric column, which will just say if this column is numeric or not. And if this is a numeric column, I am going to handle the null values here, because for numeric column, missing value will be translated as nulls. And then I'll just continue to the other column in the slope here. Then I will be just left with the categorical columns here. Okay, this is handling for numeric column, and we can just handle the categorical column here. Now, how do we handle these two types of columns? For the numeric columns, I will replace nulls with mode of the column. So mode is just a value with highest count in the data set. And for the categorical column, I will replace null and empty strings with unknown token. Okay, now, this is probably not the best way to handle null values for a mission critical machine learning task, but we are just developing a silly little game, so this will suffice for the job at hand. I'll just go ahead and do it for this use case. Now, for the numeric column, we are planning to replace all the nulls with mode of the column. Now, to calculate mode of the column, we are going to use what is called a value counts. This is a data frame value counts, which we can calculate using this method, value counts, and this will return a data frame. So value counts will be a data frame, is a data frame with two columns, values and counts. Okay, so this is actually a data frame with all the unique values of the column, and we'll also get the count for each columns. So for example, let's say the column had data like 1 3 2 4 5 2 3 4 4 5 4. Let's just give some random values. Then the data frame will have two columns, values and counts. So in the values we will have the distinct values from this array, 1, and then we have 2, and sorry, we have 3, and then we have 2, and then we have 4, and we have 5. Then 2 is already repeated, 3 is already repeated, 4 we have 5. Okay, now for the counts column, how many occurrence is there for 1? Just 1. And for 3 we have 2 occurrences, so this is going to be 2. And for 2 we have 2 occurrences, so this is also going to be 2. And for 4 we have 1 2 3 4 occurrences, so this is going to be 4. And 5 we have 2 occurrences, so this is also going to be 2. Okay, so this is how the value counts data frame will give us all the unique values with their counts. Now it should be evident from this example what is the mode for this column. The mode is obviously 4 because it occurs the highest number of counts. It has 4 counts. Now, how do we get this value, the 4, which is the mode? Okay, I'm just going to write mode here. So how do we get this? We can order this data frame. I'll just call it mode. We can just order this data frame using this order by descending method. I can give the name of the column counts. Now I have ordered by in descending order by the counts column. I will get the row with highest value for the counts at the top. So this row will now move to the top. Okay, so I can just get the first row for the value column. Okay, now after I order it, this row will move to the top, and to get the actual value, I'll just query the values column, and I just need the first row of this. I hope this is making sense to you. Now, if you notice the type of the mode, it's object, but we know that this is a numeric column, so we can safely cast this as a float. Okay, now we have the mode computed. How do we actually replace in the column? We can just use this method fill nulls, and I'll just give the more as parameter. Now this should replace the null values. Now, as an example, let's first see the data before replacing the nulls. I'll just see the data for one of the columns. Sorry, one of the rows. I'll just take the first row. Okay, so column dot name and data frame column dot name. I'm just going to take the first row here. So we'll see all the data for the first row before we handle the null values, and we'll also see after replacing the null values. Now, if you see the first row, we have a bunch of null values here, right? For some of the columns, we will see what the null values are and what happens after the replacement. And I'll also add one new line here. Okay, let's run and see if our code actually worked. Okay, so before replacing nulls, we have missing values for rate of interest and upfront charges. And after replacing nulls, also we don't have the values for this. So something should have been wrong in our code. And here it is. So in the fill nulls method, it actually returns a new column with the null elements replaced by a value. But the thing is, it does not make any change in the column that we are operating on. So to make the change in place, we have to pass this parameter conveniently named in place to true. So if we do this, the replacement should work as expected. And it does work. So the rate of interest and upfront charges are now replaced with proper numeric values 3.99 and 0. Now this works for the numeric columns, but we also have to handle categorical columns. I'll just remove this from here. For categorical columns, we need to replace both nulls and empty strings with unknown. Now, unfortunately, we don't have a method similar to fill nulls. So I'm just going to look through the rows using a convenient for syntax here. I'll just leave it I0. What is going to be the length? It's just going to be the total row counts, which we can get using this rows.count property. By the way, you can do the same for columns also. You can do data frame.columns.count to get the total count of the columns in data frame. And now I'm going to check if the values are null or empty. I can just get the value by indexing the column first and then giving the index of the row. Now the data type for this will also be an object. To convert it to a string, I'll just use the toString method. Notice I have also checked for null here because there is a chance that this is going to be null. Otherwise, what is the purpose of handling the null values? Okay, so if this is null, we can just do a simple reassignment. Okay, I'm just going to copy this bit here. I'm just navigating in the data frame to this column, whatever column we are handling right now, and I'm going to the index of the row, and from here I'll just replace whatever we have with the unknown column. Sorry, with the unknown token. Now to check this, we need one row where the where one of the string column is null, and I think I have it here for the 8th row. But let me see if we are actually using the loan limit in the relevant columns. We are not. Okay, so let's see something else. Hmm. Uh, what can we use? I'll just add this loan limit as an just to see the null value replacement. I'll just add that here. So we have loan limit in the relevant columns, and we have for the eighth row, right? So for the eighth row, we can see if it actually got replaced or not. So I'll see for the eighth row, which will have index of 7. Oh, not here. So let's see if this replacement worked or not. Okay, so the loan limit before replacing null values, we are working with the categorical columns here. So the loan limit was missing before, but after we replace the null values with unknown token, it's just unknown. Okay, so I hope this makes sense to you. Let me just remove this loan limit because we are not using this column, and I will also remove this part because this is no longer relevant. Okay, so this is going to be the final version of our code where we have load our data in the data frame. We have renamed the columns to lowercase. I'll just leave the comment here. Rename columns to lowercase. And we have selected the relevant features for us. And we have also handled all the null values for both numeric and categorical columns. So the next step is to actually train the model. Okay, so now we are ready to actually train the model, and I'll just move this comment here because it's actually relevant only when we're training the model. Okay, so now we are going to train the model, which is a binary classifier, and we are going to do this using the Microsoft.ml package that we have referenced at the top here. Notice everything we did up until this point was provided by the Microsoft data analysis package, and we were mostly working with the data frame. Now when we are training the model, we will use what is called ML context, and this comes from the Microsoft.ml package. Okay, now we are moving into the machine learning task. So as I have already said, we are training a binary classifier which will require two different types of columns, features and label. We have already identified what are the features and what are the labels for us, but I'm just going to have that explicitly mentioned here. So the label column name for us is status. We are also going to use this later. Okay, and the way we are going to train this model is through what is called a transformer in this Microsoft ML package. Okay, so what we are going to build is called a untrained transformer first. Okay, so this is just a pipeline explaining with steps to transform the data to weights of the final model. Okay, so we're going to first develop the pipeline, and then to train the model we will have something called I'll just say untrained transformer here. I will develop this in just a minute, and then we are going to have to fit with the data with schema. Okay, so this is something called I data view. Okay, now fortunately the data frame that we have been using so far implements this interface iDataView, so we can just use the data frame as the parameter in this fit method. Now this will actually prepare the model for us, and we can save this. Okay, we can save this. I'll just say saveable or can be saved. for future use. Okay, and then to make predictions, or let's just say actual transformations we need to do. So after we fit, okay, so this model will be a trained transformer. Okay, let me just enable this option so we can see it better. So to make the predictions, we need to do something on the trained transformer. We need to do what this we need to call this method transform, and here we need to pass the, I'll just say, actual data, okay, on which we want to make the predictions on. And this also has to be of the type IDW. Okay, so this is how we are going to train and use the model for making predictions. This, I think, this will make more sense once we start doing the actual coding. Now, in the untrained transformer, the pipeline which we are talking about, we will have a bunch of things. Okay, so the first thing we need to do is encode the categorical columns. Why? Because everything in the model has to be numeric. Okay, because machine learning models are mathematical models and they cannot work with plain strings. And the next thing we are going to do is feature concatenation. Why? Because we use the X matrix as input. Okay, right now we have all these columns, right? We have all these columns in the features, but when we are actually doing the mathematical things, uh, matrix operations to be specific, we need all these independent columns concatenated is a single matrix. So this is what feature concatenation will do. And the last thing we'll do is normalization, and this is just changing mean to 0 and variance to 1. You don't even actually need to know what mean and variance means for this project, but it's good to know. And this we do for to improve speed and stability of the training process. Okay, so these are the three things that we will have in our on-train transformer. Let me go ahead and do this real quick. I'll just call it a data processing pipeline, and we will use the ML context that we have defined, and we will get all these methods that I have been talking about in the on-train transformer from the transforms namespace. Okay, so the first thing that we want to do is on the categorical columns, we want to do one hot encoding. Okay, so I already told you encoding the categorical columns means converting them to numeric, and in our case, we are going to use one hot encoding. Now we need to provide the columns on which we are going to do this. We notice we need to do this only for the categorical columns because numeric columns are already numeric. And what are the categorical columns we have? If you see, uh, uh, we have all the columns here, but the categorical columns are the ones with string values, which are just age and reason. Okay, just these two columns are categorical in our case, but instead of hard coding those, we can just filter through the columns and select the numerical ones. Okay, now before I do this, I want to have all the uh, columns in the data frame in one array. I'll call this features columns. Okay, and these are, I'll just create the array using split syntax dot columns. I'm going to select all the column whose name are not the label column name. Okay, so what is the, oh, I need to go where it was. Okay, so I have just filtered all the columns which are not the label columns, meaning that I have all the feature columns in this array. Now, while doing the one hot encoding, I need to create something called input. Yeah, so I need to create something input output column pair for to operate to do one hot encoding for all the columns at once. And for that, I'm creating this array using the spread syntax. Once again, I'm going to select the feature columns, and I'm going to apply a filter here to make sure I only select the categorical columns. Okay, so this will tell me this will filter all the categorical columns here, and then on top of this, I'm going to map each column to input output column pair, and to create the pair, I need to give what is the input column name and what is the output column name. Okay, I'll just explain this in a bit. Let me just complete the code first. Okay, this is how we do the one hot encoding. I hope this is not too confusing. So why do we need to provide this input output column pair is because when we do the encoding, we actually convert the already categorical column to a new one, the new numeric columns, and it is customary to preserve the old column and create a new column for the numeric purposes. For example, in our case, the age is the categorical columns, right? And after we do the one hot encoding, we want a new column, uh, probably with name is encoded, and to tell this method one hot encoding, like what is going to be the name for age column, we have to pass this input output column pair, where the output column name should be age encoded and the input column name should be age. Okay, but in this case I am just replacing the old column after encoding, so I can just get away with providing the single output column name. I hope this is making sense to you. Now we have this pipeline ready. Okay, so this is an on-train transformer. Okay, now what I can do is I can just to see a demo, I can actually train the model with just this process, just one hot encoding. I can fit with a schema, and then I can transform with the actual data to see the transformations made. Okay, so let me just for the sake of demonstration, I'll just say d4 transform. Okay, and I will, let's just see the data for the first row. Actually, I think I can just do this now. Okay, because we only want the names of the column, so this should be fine. uh, Column name, and from the data frame I'm going to select the column first and then the first row. Okay, and I'm also going to see this after the transformation. Yeah, okay, but the thing is I haven't actually done the transformation. I just created the pipeline, which is an on-train transformer. So to get the transformed value, transformed, what I need to do is on the data processing pipeline, I need to first fit the data. I'll just pass the data frame, and I need to do the transformation as well. Okay, and I'll just copy this and paste it here. Okay, so the thing is it will return I data view, not the data frame. So I just need to convert it to data frame, and this will actually take the value for maximum rows that it will consider when converting I data view to data frame. I just need the first row, so I'll pass 1. Max rows, I'll just pass 1. Okay, this is missing here. Let's just run this and see what happens. Okay, so before transform, we have all this data, and after transform, if you see, so most of these other columns are exactly same, like income is same, credit score, it's the same. But age and reason, these two columns have changed. Okay, so age was 25 to 34, but now it's something called sparse vector of size 8, and we only have one explicit values. Now what this means, let me just try to explain it a little better. I'll explain with the example of reason column. So if you see in the reason, where is the reason? Okay, so this is the reason. Okay, now if you see the reason, we have south, north, right, and then central, and probably one more. Now let's just say east. I can't find it. Okay, let's just assume that it's east. So how this one hot encoding works is, for the reason column we have four values: north, south, central, and east. Okay, let me just verify that. Oh, it's northeast. Okay, northeast. Okay, and let's say for the first row, what is the value for the first row? The value is, I can just see it right here. It's just south. Okay, it's south. And during the one hot encoding, what it will do is, instead of having this string value, it will convert this into uh, it will convert this into a vector. Okay, we saw sparse vector of size 8. Sorry, for reason we saw of size 4. Now this 4 comes from the number of unique values in this column, which is 4. So it will create a vector of length 4. Let me just fill with all zeros. And then for the value, okay, so now these all these entries in this vector correspond to one of these unique values. So in our case, maybe this 0 corresponds to north, this 0 corresponds to south, this corresponds to central, and this corresponds to northeast. In our case, in the first row, so the second entry of this vector is going to be 1. And the reason it's called one hot encoding is because for each row, okay, for each row in the uh, reason column, we will only have one of these element 1. Okay, because it cannot be both north and south at the same time. So if you notice, for both of our categorical columns, age and reason, the size of the vector is the number of unique values, but we will only have one explicit value. That is the reason it's called one hot encoding. Okay, I hope this is making some sense to you. And we also saw how we can create an untrained transformer, train it, and fit it, and then transform to actually do the transformation. But the thing is, if you see, we did the transformation on the whole data frame, but when we are training a machine learning model, we actually do this on a subset of the total data. Okay, so we call that, we actually split the data frame to two subsets: train data and test data, and we call this process train test split. Okay, so we usually preserve some of the data for testing purpose so that we can test the model on the new data which it has not been exposed to. And to do this, we actually have a very convenient method from ml context.data. We have this method train test split. Obviously the first argument is going to be the data, which is our data frame, and one important parameter is test fraction, which I'm just going to give 0.15. Now what does this mean? 0.15 of test fraction means 15% of the data is used for testing and remaining 85% for training. Okay, and we can now get the training and testing data. I'll just say train data is train test data dot the train set, and notice that this is an I data view, but for our easiness, I'll convert this to data frame. Okay, and if you remember, it takes this argument max rows, which by default is 100, but in the training data we actually need more than 100 rows. So I'll just give the total row count of our original data frame here. Notice that this is the maximum value, so even if it is less than this, we will not have any problem. Okay, and similarly I will also do for the test data. Oh, uh, I should see the test set and everything else will remain the same. Okay, so and whatever we do now onwards, whatever we do, so this can remain as it is. I'll just mm, yeah, I'll just put the code here, train test split. Okay, and now whatever we do, we are going to do training on the train data instead of the original data frame. Okay, uh, okay, so let me just remove this part of the code. I'll also remove this. Okay, and with this I think we're good to proceed. Okay, but okay, before we do anything, I'll actually like to save this train data and test data from using the static method. Save CSV, the train data, and okay, now we need to give what is called okay, so the path to save this, which is just going to be train data.csv, and for the other one, test data, I'm just going to say test data.csv. Okay, so I'm going to save train data and test data, and we are going to see one very important thing here. Okay, let me just run this code first. Okay, so the code has been run. If you let's see the test data first. So the one thing that I wanted to verify with training testing split is if we have both status 0 and 1 in this data set. Okay, now if we miss like status equals to 0 in the training data, that means our model will only be able to predict status equals to 1. So it will always predict status 1. So it's important to have both of these status in the train data. Okay, let's verify that first. In the status column I have 1 and I have 0, so I'm good on the trend data. Similarly, we also need to have both status in the test data, because otherwise, let's say if we have only status equals to 0 in the test data, there is no way to verify that the model will actually predict the correct result for the missing status. Okay, so in our test data I have status 0 and I have status 1 too, so we are good. Okay, now that we have done the first step, that is train test split, and now we are going to build the actual transfer on train transformer with this comment. I think it's better if we keep it here. Okay, so the next step is to complete this pipeline and then train the model. So to train the actual model, we first have to complete this untrained transformer pipeline. Okay, so now we only have this encoding implemented. Let's go ahead and do feature concatenation and normalization real quick, so we can actually append. Okay, so if you see the type of this, okay, the return type, it's estimator, something called an estimator, and what we can do is we can append other estimators in the same in this one to actually create the pipeline. Okay, so I'll just do append here, and I can just create a uh, new estimator. Okay, so the next thing that I'm going to do is something called concatenation, concatenate. Okay, so this will join all our feature columns into a single column, and that column will form the X matrix that we are talking about. Okay, so to concatenate, I need to first give the output column name. Okay, so the first parameter is output column name, and the second parameter is name of the input columns. So the output column name, I'm just going to call it features, and the input column name we are going to have to get from the feature columns. Okay, so feature columns dot select column dot name. Okay, so we actually, let me just make it a little more clear. Say output column name in this, and this is input column names. Okay, okay, and we have the encoding is done here, feature concatenation is done here. Then last step is normalization. Context dot transforms dot normalize mean variance. Okay, and this will just take two um, sorry, this will just take two parameters, output column name and input column name. Okay, so the output column name, I'm just going to give normalized features, and the input column name, I'm just going to call it features, because whatever is the output of concatenation, we have to use this is input in the next step. Okay, so just to avoid reusing these features, I'm going to where do I do that? Yeah, this seems to be a good place to do that. Features column name, features. Okay, and I'm just going to copy this, use it here and here. Oh, it's in quotes for some reason. And this also I'm going to do this way. Okay, so we have done all the three things that our transformer is required to do, except of course for the very important thing, we are going to have to train the classifier. Okay, so to do that, that is also nothing uh nothing except the estimator, but instead from the transforms, now it will come from model. Oh, sorry, it will actually come from binary classification namespace. And there are a bunch of options we can use at trainers, but I'm going to go and use this one. This is a simple linear binary classification model which we are going to use. Okay, and is the now we can pass a lot of things to this trainer. Okay, we can pass a lot of hyperparameters, but we are not going to bother with everything. I'm just going to give two very important parameters. First one is label column name, which is the label column name, and features column name. Okay, so we are going to reuse this also, because remember, whatever is the output from from this step will be used as input in the next step. Okay, so let's just cut it and define it here, and I'm going to use this here and here. Okay, so now it will only use the normalized features column is the matrix X matrix, and is the output or the prediction column, it will use the label column name. Okay, to train the model. Now if we need the model, okay, so let's actually do the training here. Okay, I'll just call it model. What we can do is data processing pipeline, which is the untrained transformer, and we can call the fit method with anything. So it can be trained data or test data or the data frame itself. Just the schema matters at this step. Okay, and after we do this, we can actually save this for future use, right? So let's just go ahead and do that real quick. So what we can do is ml context dot model dot save, and the first argument is the model to save, and the second one is, oh, I don't know why it's not showing that. Okay, but we just need to pass the schema. Okay, input schema. Now the input schema can be uh, anything, but I mean we can get this from any data frame. I'll just use the train data, or let's just use the data frame. But the thing is, it has to come from the iData view interface. So I'm just going to cast it as iData view and schema. So this is just something we have to pass, data view schema, and the last parameter I'm going to give is the path, which is just model.zip. This is going to be a zip file, so I'm just going to give the extension as well. Okay, so I hope this is straightforward to you. We are just training the model and saving it. Now let's just run this code first. Okay, let's just see what we have so far. Okay, it's taking some time. We got an error. Okay, so the error says schema mismatch for label column status expected boolean got single. Okay, what this means is for the trainer that we have used, actually I think I'll just leave these comments in the appropriate places. Hmm. Okay, so this is clearer now. Okay, so we have this done, but the thing is the status column that we are using to train has to be boolean, so we need to convert this. Okay, so I think yeah, we can do it right here. Okay, so before even splitting the data, let's just convert the status column to boolean. Okay, now how do we do this? First we will create a new column. I'll just call it boolean status column. Okay, and this is going to be something called a primitive data frame column, which can hold any primitive values. In our case, this is just a bool, and we need to pass the name of the column as the first parameter, which is just status, and then we need to pass the actual data. Okay, which this data I'm going to form using the old column. Again, it's using the spread syntax. So data frame dot actually it's just query through the column name, and now we cannot directly work on this data frame column. So the type of this column will be data frame column. Instead we need to cast it as a column containing some value. Okay, so I'm just going to cast it into a column with float values, and now on this I can do the link query select, and I will have the status values which are just 0 or 1. So to cast this into boolean, I'll just do this. Okay, now what this piece of code does, it will first cast the status column here into one of the type which contains some values. In our case, it will contain float values because this is a numeric column, and we map through all the values in that column, convert those to boolean by comparing if they are actually equal to 1. So status equals to 1 will convert to true, and status equals to 0 will convert to false. Now to make this IDE happy, where it's saying that this column may be null because whatever the label column name, it may not exist in the data frame, but we know it does. So I'll just say this will never be null by adding this exclamation sign here. Okay, so this is the boolean status column. Now I'm going to remove the label column, the old label column, and I'm going to edit the new one. Okay, boolean status column. Okay, so how can we verify this is through train data and test data. Okay, let me just run this code real quick. Now it's taking some time. Okay, it's done. So now if I go ahead and look at my test data, for example, I can see the status column are all Boolean. So this is status false, this is status false, right? And if I also go ahead and see the train data, then I can see that the status are true or false only. Okay, so this means this conversion is complete, and also I did not get any error this time, so my models would have been saved. Yes, it is with the extension zip. Now we only have one more thing to do, which is to actually use the test data in making the predictions and evaluating our model against some standard metrics. So let's go ahead and do that. Okay, so to make the predictions, I'll just call these predictions. What we can do is we can use the train transformer. So if you see the type of this model, it is a transformer chain. So this is what the trained transformer is. Okay, now I'm going to use the model and call the transform method on the actual data. Now this has to be the data on which we are making the predictions. So we are making predictions on the test data. So I'm going to use that, and I have the predictions ready. Okay. Now we are actually not interested in the predictions themselves, but we are interested in how the model uh, is performing with this test data. For that, I'm going to calculate matrix. Okay, and we are going to use the same model context binary classification dot evaluate, sorry, not equals, evaluate. So the first we are going to pass data, which is the predictions. Okay, now this will also be a data view. Okay, you can convert this into data frame and see all the columns and all, but we can also let's see. Yeah, so we can also see the columns names here. By default, we will have these columns. Okay, label will just be the status column in our case, and we'll also have score. Okay, let's not worry about this too much. And this is the other one, probability. So this will give us the probability of the prediction. Okay, so for example, if the model predicts that the loan is defaulted for some row, it will also tell us what is the probability of actually being defaulted. So if it predicts that the loan will default, this will be greater than 0.5, and if it predicts that it will not default, this probability will be less than 0.5. Okay, and for the predicted label column name, it will just use this predicted label by default. Okay, now in our case we don't have to change anything except the label column name, because it's not label. Okay, it's it's label column name. We already have that saved as label column name, which is status in our case. So let's just evaluate and see the metrics also. Okay, so from the metrics, there are a lot of things we can see from the metrics, but I will just show you the accuracy of the model. Metrics dot accuracy, and we will see something called the confusion matrix as well. Okay, you can explore what the other metrics mean on your own, but these are the only two things that we're going to look at. Okay, so matrix dot confusion matrix dot get formatted confusion table. So this will just give us a nice string to view in the console. Okay, let's just run the whole thing again. Oh, oh, I got a very weird error. Let me just delete this terminal. I don't know what that was, and I'm going to start a new session. Okay, hopefully that will not repeat. Oh, it repeated. This is weird. Ah, this also does not work. Okay, so the reason it failed was not very clear to me, but I think after I cleaned the file and then run it, it should work. Hmm. And it does. Perfect. So if you see, the first thing that we want to note is the accuracy of the model, which is higher the better. It can be between 0 and 1, but if it's exactly 1, then it will mean overfitting, which is also not very good. In our case, it's 88%, which is pretty good for our use case. And I'll just ignore this test positive ratio for now. Let's go to the confusion table. So here we have a table with predicted in the column headers and truth in the row headers. And we also have this recall and precision. I'll explain what all these mean. So if you see, let's see the value for the first cell. Okay, in this case, the predicted values are positive and the truth is also positive. Now, positive just mean status is true. Okay, status true means loan is defaulted. So for the first value, okay, we had the actual truth positive, meaning the status was true, and the model correctly predicted for all these values the status is true, positive prediction. Okay, so this is good. Having this a high value is good. Okay, higher the better. If we move to this cell, then for this the actual truth was positive, but the model predicted negative. So even for the defaulted loans status equals to true, the model predicted status equals to false. So this is bad. Lower the better. This number has to be lower. Okay, and for this cell here, it's for this one the actual truth was negative, but our model predicted positive. So this is also bad. Lower the better. And for the last cell, the actual truth was negative and our model correctly predicted negative, so higher the better for this cell. Okay, so I hope this is all making sense to you. Now let's move to what recall and precision mean. Now recall means, okay, so this is just a ratio from this row, okay, which means for the actual positive values, how many for how many rows did our model accurately predict positive. Okay, so what the positive recall means, the fraction of the actual the fraction of the correct predictions made for the actual positives. Okay, so for 86% of the actual positives, our model correctly predicted positive. Same thing for the negative recall. It's just the ratio of this number to the sum of these. This tells us for the for what percentage of the actual negative rows, negative predictions, negative values did our model correctly predict negative. Okay, so for almost 15,000 rows that were negative, our model correctly predicted negative. So that is what this recall means. This also has to be this also is higher the better. In our case, it's 89%. Now moving on to the precision. So precision means out of the predicted positives, how many were actually positive. Okay, so this is the ratio of these column values. So ratio of this to the sum of these, and it's actually 72% for us, which I think is pretty acceptable for our use case. And similarly for the negative precision, this means out of the total negative predictions, how many were correct. Okay, it's simple as that. Now in our case, these metrics are okay enough for a game that we are trying to build. So I'm not going to optimize this, but I highly encourage you to. The one thing that you can do is you can try this for a different combination of relevant columns, okay, and see how this works. The other thing you can do is probably handle the null values uh, in different ways, like instead of just replacing all the nulls with mode, or you can actually find the nearest row with not with that does not have the null value and actually replace with that. For example, you can see which of the rows have the closest loan amount and find the value of this column in that row and replace it with that value instead of mode, but that's too elaborate for this project. So I think this is it for the first task of this to-do list, and I think this is also enough for a single video. I hope I will be able to see you in the next one, and thank you for watching the video. I hope you enjoyed this project so far as much as I did. Thank you for watching. See you in the next one.